Okay, grade 9, this is your final review for chapter 5 on polynomial addition and subtraction. So your first question says 4x squared and negative 4x are like terms. 4x squared are like terms. Now remember, this is what makes a like term a like term. So the first thing they need to have is the same variable or variables in the term, and in the case of 4x squared, the variable in this one is x, and the variable in the other one is x. They don't have an xy or an xyz, just an x, so they're the same variable. And the same exponents on those variables. So if we look at the x's, this has an exponent of 2, this has an exponent of 2. So therefore, they are like terms, and it's true. Remember, the difference really can be coefficients can be different in like terms, but not the variable or exponent combinations. Question 2 says a trinomial 4x squared minus 2y squared plus 6 has a degree of 2. Now remember, for this one, what it's really asking you to do is if you have a trinomial, do you know how to calculate the degree of any polynomial, whether it be a trinomial, binomial, or a 10-term polynomial? The degree of the entire polynomial is determined by looking at each term. So that's term 1, term 2, and term 3. Term 1 has a degree of 2 because degrees are determined for a term by the sum of the exponents within the term. The second one has a degree of 2 as well because it has a y squared, so its degree is there. And the constant does not have a variable, so therefore has a degree of 0. And therefore, if you look at all of these three terms' degrees, the one that has the highest degree is a tie with 2. So therefore, the degree of the polynomial is determined by the highest term's degree, so therefore it's true. The entire trinomial has a degree of 2. Now on a test, I might say something like has a degree of 4, and some people will get tricked into thinking that you add up all the exponents within the entire trinomial, but that would be a false answer if I did that. Question 3. When arranged in descending degree of terms, the polynomial negative 4x to the exponent of 4 plus 3xyz minus 6x squared would become negative 4x to the exponent of 4 minus 6x squared plus 3xyz. The answer for this is false, and here's why. If you take this trinomial, I'll make it a little bit bigger for you, and I look at each term. There's one term, there's a second term, there's a third term. The degree of this term is 4 because the exponent is 4. But the degree of this term, there are three variables. There's an x, a y, and a z within this term, and each of those has an invisible 1 as its exponent. So therefore, if you look at x, y, z, it has a degree of 3 because each of those is 1. And this one has a degree of 2 because the exponent on the x is just 2. So therefore, it is actually already in proper order in descending degree of terms because this is the second highest degree term. Hopefully that made sense. Question 4, the opposite of 7x minus 2x squared is negative 7x squared plus 2x. The answer for this is false. And here's why. If I take this term, what I need to do is I need to know there's two terms. There's this one and there's this one. And the opposite of each of those terms, the opposite of positive 7x is negative 7x, not 7x squared. And the opposite of plus or negative or minus 2x squared would be plus 2x squared or positive 2x squared. So the opposite is actually this instead. Question 5, we have a binomial, take away a binomial, and according to this, it says it's equal to nothing. So in order to solve this subtraction, remember you keep the first polynomial as is. You change the subtraction to addition, and you use the opposite of each term within the second polynomial. So we're going to change it to a positive 5x squared and a positive 4. When I gather like terms, a negative 5x squared and a positive 5x squared are going to make 0. But a positive 4 and a positive 4 do not make 0, it makes 8. So the answer is false. The actual difference between those two is 8. Question 6 is the addition of two polynomials, in this case two binomials. And the first binomial plus the second binomial, according to this true-false question, is equal to 1. So here we don't keep flip change because we already have addition. So we're going to gather like terms. An 8x squared and a negative 8x squared are algebraic 0 pairs, so it makes nothing. And a negative 7 and a positive 7 make 0, so it's not 1, it's equal to 0 instead. So the answer is false. Question number 7, which is not written 7, but it's 7. What is the expression modeled? So remember, the big ones are actually x squareds, and if it was not shaded in, it'd be a negative x squared. These are each negative x's, so there's 3 of those. And these are each positive 1, so there's 2 of those. So we have 1x squared, and we already said before we never write coefficients of 1, so we're going to erase that. We have 3 negative x squared. So these 3 negative x squareds, we have negative 3 negative 3 x's, not x squareds. So we have negative 3 x's, and we have 2 of these, which is going to be a positive 2. So we have plus 2 or positive 2. So that's what the expression is right there. Question number 8. Identify each expression as a monomial, binomial, trinomial, or polynomial. State the number of terms and the degree of the polynomial. So the first one, 2x squared, is a monomial. IAL. How many terms does it have? It has 1 term, and the degree is a degree of 2 because the exponent 2 is attached to the only variable within the term, so therefore it's a degree of 2. The second one is a trinomial, which means there's 3 terms, 1 term, 2 terms, 3 terms. And the degree of the entire polynomial is 2 because the degree of the highest degree term is the second term, which has a degree of 2. So the entire trinomial has a degree of 2. The C, 10 minus x, is a binomial because it has 2 terms, this term and this term. It has, 2 terms, and it has a degree of 1 because the x, even though it's not written, has an exponent of 1 attached to it, but we don't write exponents of 1. But that is the term with the highest degree, and therefore the binomial has a degree of 1. And finally, B is simply a monomial. It has 1 term, and the degree of that is 1 because the unwritten exponent is 1. Next question says, which polynomials are equivalent to 5x squared minus 2x plus 3? So for the first one, oh, sorry, just say yes or polynomial, so I better move this over here. So the polynomial is given here, and it's either yes or no. Okay, so let's see. And down here. Okay. So the first one, 2x plus 3x plus minus 2x squared plus 3. What I'm going to do is gather my like terms. So the first thing I'm going to do is gather all my x squareds. I have a negative 2x squared. That's the only x squareds I have. I have plus 5x, which are my x's. And I have a plus 3. And when I look at the equivalent to this, I say, no, it's not. So it's not equivalent to that. The second one, if I gather my x squareds, there's 4x squared and another 1x squared, which is 5x squared. Just add your coefficients. A negative 2x is the only x term. And then minus 5 and plus 2 would be a minus 3. So therefore 5x squared minus the first 2 terms there, but the constant of minus 3 and positive. So this one is not equivalent to the term above. This one here. Next one, I have 3x squared and 2x squared, which is 5x squared. I have a minus 2x with no other terms to combine with it. And a positive 4 and a negative 1 makes a positive 3. So therefore this is equivalent to the term I circled above. And finally, negative 3x squared and positive 8x squared is 5x squared, or positive 5x squared. A negative x and a negative x is a negative 2x, and a positive 3. So therefore, this one is as well equivalent to 5x squared minus 2x plus 3. Your next question, 5x minus 4xyz plus 6x squared minus 12 is a 4-term polynomial. When reordered in descending degree of terms, what would it look like? So what you have to first realize is that this has a degree of 1, this has a degree of 3 because 1, 1, 1. The second, 6x squared has a degree of 2, and minus 12 has a degree of 0 because it's a constant. So the degree with the highest, the term with the highest degree is the second term. So now a lot of people are going to do this, but it's wrong because this is attached to the actual term itself. So it's a negative 4xyz or a minus 4xyz. So we want to keep that negative sign with it. A lot of people forget to do that. The second highest degree of term would be the third one, which is positive 6x squared, which has a degree of 2. and we have a plus 5x. Now, even though the plus is not written here, we understand that's a positive. So we're going to write the plus 5x and the minus 12. That's what it would look like right there. Your next question says, write the model as the sum of two polynomials and combine like terms. So this would be 2x squareds, positive x squareds that is, minus 2x, negative 2x's, and plus 2. That's your first trinomial. Plus this polynomial would be a negative x squared and a negative x and a negative 2. So the first thing you're going to do is write your addition of two polynomials like that, two trinomials in this case. And because you're adding them, all you're going to do is gather like terms. Now, if you want, what I said you could do is you could take your pencil, if you have a difficult time seeing it, and box them up. All right, that way you can kind of see it, and make sure you include the plus minus sign with your term so you know if it's positive or negative. And gather your like terms. So the first ones we're going to gather are the x squareds. There's 2x squareds there, and a negative x squared, or a negative 1. So a 2x squared and a negative 1x squared would make a x squared, or a 1x squared. We won't write coefficients of 1. A negative 2x and a negative x makes negative 3x. Remember, this is negative 1x. If you combine that with a negative 2x, you would have a negative 1x and a negative 2x, giving you negative 3x. And finally, a negative 2 and a positive 2 make nothing. So when you combine those two trinomials, you end up with a binomial of x squared minus 3x. The next one would be 2x squared minus 2x plus 2, not 1, minus x squared minus negative x squared minus x minus 2. So here, because we're subtracting, we're going to change it to addition, and we're going to use the opposite of each term within the second trinomial. Gather your like terms. 2x squared, this is now a positive x squared, which is going to be a positive 3x squared. A negative 2x and a positive x is going to make a negative 1x, which is negative x. And a positive 2 and a positive 2 is going to make a positive 4. So when you find the difference of those two polynomials, the difference would be 3x squared minus x plus 4. Draw to solve and circle your solution. So here we're going to draw an x squared and two negative x's and a plus 3. And to that, I'm going to put it in brackets, I'm going to add, that's an add sign, negative 3x squareds, a negative x, and a negative 4. So this x squared and this negative x squared are going to make an algebraic zero pair, leaving me with negative 2x squareds here. So they're gone now. These two negative x's and this negative x are not going to make any zero pairs, but combine to be negative 3x. They're gone. And the positive 3 and the negative 4 are going to combine to make 3 zero pairs, leaving you with just a negative 1 left. Again, the next one would be 4x squared, which is 1x squared, 2x squared, 3x squared, and 4x squared, plus 5. And to that, we're going to add a negative 3x and a positive 5. So here it's pretty easy because there are no zero pairs at all, right? We simply have your 4x squareds, which are going to remain as 4x squareds. We're going to have your negative 3x, which remains as your negative 3x. And the 5 here and the 5 here are going to combine to make a positive 10 or a plus 10. And there's my solution. Toby simplified the 7-term polynomial into a binomial. What error did he make? So let's look. Toby doesn't usually make errors. This is weird. So we have this 7-term polynomial above, and I'll take my highlighter, and I will highlight said terms. There's the first term, the second term, the third term, the fourth term, the fifth term, the sixth term, and finally the 7th term. Woo, 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 woo. So when we look at those 7 terms, and I look for the highest degree term first, I'm going to do my x squareds. 3x squared and positive 2x squared is going to be exactly what Toby got, which is 5x squared. You did a good job on that. Then I'm going to go for my negative 2x and my negative 5x. And that's going to be a negative 7x, which Toby got right here, which is great. So far he's doing good. And finally, a negative 4 and a positive 2 and a positive 2 is going to make 0, not 1. So Toby's error came right there, right? You should have had a 0 or nothing there for a constant because they would have canceled each other out. The next question is the addition of 3 polynomials together. So there's no real difference here. Just make sure that when you do it, you gather like terms properly. So 2x squared and negative 3x squared and 4x squared. That's going to be a 3x squared when I add it all together. A positive 3x squared. A negative x and a positive 2x is going to be a positive x. And a positive 5 and a negative 1 is going to be a positive 4. So when you add up those 3 polynomials, you end up with 3x squared plus x plus 4. The next one is subtraction. And again, as we've done before, don't subtract the polynomials. It's so much easier to change to addition of the opposite of each term in the second polynomial. A common mistake is just to change the first term and not the second. Make sure you change all of the terms within the polynomial. So when you do so, you get a negative x squared and a positive 2x squared, which is going to be a positive 1x squared. So your x squared terms are done. A 7x and a negative 3x is going to be a positive 4x. And your constant of negative 1 is going to be remained as negative 1. Done. Your next question is the addition and subtraction. You got to be careful in these questions of 3 different polynomials. We have a trinomial, take away a trinomial, plus a binomial. So the only thing you have to remember is change your subtraction to addition and use the opposite of every term within that trinomial. Don't do the whole thing. Yeah, just make sure that you change them all to the opposite within there. Now notice I didn't change these ones because those are still addition, so I didn't have to. Okay. So now that you did that, gather your like terms. A negative 5x squared and a positive 8x squared is going to make a positive 3x squared. Now, if you put the positive sign there, it's not wrong, but just know that it's superfluous. You don't need it. A negative 2x and a positive 3x is going to make a positive x. And a positive x and a negative 4x is going to be a negative 3x when you gather them. And a positive 7 and a positive 8 make a positive 15. Take away 1 is a positive 14. And finally, your last one says complete the addition pyramid. So this polynomial plus this polynomial gave us this polynomial above it. So with that said, since there's a 3x squared here and there's no x squareds here, we know that this one had to be a 3x squared in order to add that. And since there was an x here, but there's no x up here, we knew that this one had to be a negative x to cancel each other out. And since this is a plus 1 and a plus, this was something, but I ended up with a negative 5. A positive 1 plus what gave me a negative 5? It was a negative 6. So if you combine this binomial with this trinomial, and you added them together, you would end up with 3x squared minus 5. Now, the next one to do is figure out what this one is. This one's even easier because all we have to do is add the 2 ones below it, which would be a 3x squared and a 7x squared is going to be a 10x squared. A negative x is going to be combining with nothing. And a negative 6 and a negative 4 will make a negative 10. And once you have that, combine your final terms, which are these two, to give you 13x squared above it. The negative x is still by itself, and the negative 5 and the negative 10 make negative 15.